So today we're going to start getting into our more complicated equations. This is lesson 18.2, which is all about solving equations with rational numbers, which is a nicer way of saying that we're going to be solving equations that have a whole bunch of fractions in them. Okay, so as I told you in the previous lesson, it's really essential that you guys are following the steps that I'm teaching you to stay organized and so that you can handle these complicated equations. So if you haven't been doing it already, today is the day to start doing it because this is going to be rough, okay? So let's take a look. This is what the equations are going to look like that we're dealing with, okay? We're going to be solving 7/10 n plus 3/2 is equal to 3/5 n plus 2. So for some of you, fractions are your nemesis. There is an easy, super simple way to always handle these fractions, okay? And that involves using the LCM, or the least common multiple. What we're going to do, and I am not going to use this, the steps are here, but I'm going to do it separately so it's a little bit less crazy with those boxes. I know you guys don't like the boxes, but what we're going to be doing is we're going to be looking at the denominators. Okay, so I'm going to use this. We're going to look at the denominators of all the fractions. And if we can just figure out what the least common multiple of those, the least common multiple of the denominators are, we can multiply the entire equation by that least common multiple, and it will get rid of these fractions, and then we will be able to just deal with an equation that has whole numbers. Okay, so instead of solving this using fractions the whole time, we're gonna get rid of the fractions by using the least common multiple. So between the numbers 2, 5, and 10, we want to determine the least common multiple. Here it's pretty easy. It's gonna be 10, right? Because I know I can get 10 from multiplying by 2, and 10 from multiplying by 5, and 10 from multiplying by 10. So the least common denominator here is 10. And if you forgot what least common denominators are, I will just quickly remind you, it's not greatest common factor. We're talking multiples here, right? So you list the multiples. 2 times 2 is 1, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 5 times 5 is 1, right? It's 10, 10, and then 10 times 10 is 1. The first common one is going to be your least common multiple. We did this back in the beginning of 6th grade. Okay, so how do we do this? What we're going to do is we separate our equation. We're going to multiply both sides of the equation separately by 10. So we're going to do a big parentheses, and we're going to multiply by 10. So that means we are going to multiply the first piece by 10 and the second piece by 10. Okay, same thing goes on this side. So what's going to happen here, it's crucial that you guys paid attention to my little trick last year that I taught you. We're going to be thinking of, I'm going to write it out separately using the distributive property basically. So this is 7/10 n times 10, and then it's 10 times 3/2. Okay, and then on this side, it's 10 times 3/5 n plus 10 times 2. Now, the reason why my trick is crucial here is because it makes it so much easier. Here's what we want to be able to do. 10 goes into 10 once, 10 goes into 10 once. This cancels out completely. So this is now 7n. Now here, 2 goes into 10 once, 2 goes into 10 5 times. That gives me 5 times 3, which is 15. Now look, I have all whole numbers here. I'm going to do the same thing on this side. 5 goes into 5 once, it goes into 10 2 times. 2 times 3 is 6, and you keep the n. And then, of course, 10 times 2 is 20. So now I have just a regular old equation with variables on both sides. Okay? So the trickiest part is remembering that you need to multiply both pieces of each side of the equation by 10. So what you're ultimately doing is you're taking that LCM and you're multiplying every single term by 10. So if you separate it like this, it's a little bit easier. I don't want you guys skipping around and not showing steps. So I'm hoping that I will see all these steps on the homework, okay? and then using the trick. So when I told you guys last year this would be imperative that you guys learn this stuff and stay organized and keep up with the steps, this is why. Okay, so now we're going to solve this as a normal equation. I'm just going to extend my little line. And from yesterday, our first step was to bring any variables to the left. So this 6n is going to go over here. Since it's positive, I'm going to subtract 6n. What I do to one side, I do to the other. 7n minus 6n gives me just 1n. I'm going to just leave it as n. Bring down your plus 15 is equal to positive 20. Okay, and I'm just going to subtract 15 from both sides. And I can find nice and easily that n is equal to 5. So that would be my solution. Would you have expected to get such a nice solution from that monstrosity? I don't think so. Okay, so let's do another example to try to get this in our heads. Okay, so here's the your turn. We're going to do numbers 3 and 4 together, and then that's it. So I just rewrote the two equations to prep myself here. For number 3, what you'll notice is there is the same denominator. This is the kind of situation that you want to deal with. I want to have the same denominator because now I don't have to think about the LCM because it's going to just be 7. Right? The LCM of 7 and 7 is just 7. So what I'm going to do is I'm going to multiply this entire side of the equation and this entire side of the equation both by 7 so that I can get rid of those denominators. So what that means is I'm going to multiply each piece of each of these by 7. So I'm just going to break it up, okay? So this is 7 times 1/7k minus 7 times 6. So it's basically, you're basically just distributing, okay? And this is equal to, now this is 7 times 3/7 k plus 7 times 4. Okay? And now we're just going to use my trick to cancel things out. Okay? So 7 and 7 cancel out. 7 goes into 7 once, 7 goes into 7 once. It's just 1k left, which is the same as k. Minus 7 times 6 is just 42. Look how much nicer the side is now. Okay, and now on this side of our equation, 7 goes into 7 once, 7 goes into 7 once. I'm left with 3k plus, and now 7 times 4 is 28. Okay, look at this. Now I just have a normal equation to deal with. No more fractions. How nice. Okay, much better, much better. All right, so I'm going to bring this variable over to the left by subtracting 3k because it's positive. What I do to one side, I do to the other. So I'm subtracting 3k from regular k. Remember, that was a 1. So 1k minus 3k is going to give me negative 2k minus 42. Don't forget the minus. Is equal to positive 28. Okay, from here I'm going to add 42 to both sides as I'm doing the opposite of subtracting 42. Okay, and I'm going to end up with my negative 2k, don't forget that negative, is equal to 70. For my final step, I'm just going to divide by negative 2. What do I do to one side? I do to the other side. So k is going to be equal to negative 35. And again, don't forget you can use your calculators for all these calculations here. So it looked horrifying when we began. It looked pretty horrifying as we were solving it, but then it started to become nice. And then we ended up with this lovely, simple solution. Okay. So what I'm going to do is I'm going to tell you what the LCM is going to be here, and then I'm going to have you pause and do it yourself. So first things first, we draw the line, and we notice that we're dealing with fractions here, so we're going to say, you know what, I'm going to multiply both sides of this equation by the LCM so that I can cancel out. So in this case, I have a 4, a 2, and a 6. So if you want to do it off to the side, you can. You can think about the multiples. It's the easiest thing is to think about the multiples of the largest one because you'll get that the fastest. 6 times 1 is 6. 6 times 2 is 12. And hopefully you stop there because you realize that you can get 12 from 4 and from 2. So your LCM is going to be 12. So what you're going to do here is you're going to multiply this side of the equation by 12 and this side of the equation by 12. So pause. Try to solve this yourself. Look at the steps from the previous example and then unpause and see if you get it right. I promise it looks horrible, but then once you get through it, it's very satisfying to cross things out and end up with whole numbers. Okay, so go ahead and pause it. Voila! So I got -9/16. I'm hoping you guys got the same. If you multiply each side by 12, what you're going to end up doing is you're going to multiply each piece by 12 just like you were distributing. So it's 12 times 5/6 y plus 12 times 1 on this side. And on this side, same thing, you just separate it. 12 times -1/2 y plus 12 times 1/4. Okay, and I used my trick to cancel things out. I knew 6 goes into 6 once and 6 goes into 12 twice. And then 2 times 5y is 10y. 12 times 1 was just 12. Same thing here, but you can also do half of 12, which is 6. But 2 goes into 2 once. 2 goes into 12 6 times. 6 times -1y is -6y. And then 1/4 of 12, of course, is 3, but using the trick, 4 goes into 4 once. 4 goes into 12 3 times. 3 times 1 is 3. And then we just had this much nicer equation. Moved my -6y to the left by doing the opposite, which was adding 6y. So it was 16y plus 12. I did the opposite of adding 12, which was subtracting 12 from both sides. And I ended up with 16y is equal to -9 and just divided by 16. And that is fully simplified. And you can check that in your calculator using the math frac button if you have a graphing calculator. So this is a lot of work, guys. So I'm cutting this video short. You have the worksheet to do. I'm going to be able to tell if you watched a video or not by looking at your work. So please make sure you're doing it the same way that I'm doing it in the videos. It's very, very important to get this, basically making it into a habit so that you know exactly what to do when you're dealing with these crazy fractions. Okay? Also, please leave your answers as fractions, not as decimals. Okay, have fun with this.